Okay, this is Mr. Jern. I'm going to talk about AP Physics 1, the workbook 1E, relative velocity. So in this scenario, we have Blake and Carlos playing on a train while Angela watches. While the train passes Angela, it is traveling at 5 meters per second to the east. At this time, Blake is running at 2 meters per second east relative to the train toward Carlos, who is taking a break. He's standing still. All speeds given for Blake are relative to the train. Okay, so relative velocity, as the title of this implies, is going to be just a reminder about how velocity kind of changes depending on what you're comparing it to. Okay, so speeds given for Blake are relative to the train. So if he's moving 2 meters to the east, that's basically by compared to somebody standing on the train with him. So Carlos would see Blake running 2 meters to the east. Blake would consider himself moving 2 meters per second to the east. So part A, identify and label a direction to be positive. In the sketch above, label the positive direction. So you can honestly label any direction to be positive. I would make it easy on yourself and pick something that makes sense. So what we're going to do is choose east as positive. I think it's going to be easiest unless you like working with negative numbers. Honestly, typically east is oftentimes by default positive, not always, but in this case, it makes sense. I mean, if you think about the compass rose with north, east, south, and west, let me scooch that down a bit. Typically, north and east will be positives, where south and west will be negatives. That's just kind of like typical. There are reasons you might not want to do that, but unless you have a reason not to, that's usually a safe assumption to do it that way. So, and it actually works out for this example as well. So positive is going to be to the right. Now we had to sketch a motion map based on Angela's measurement of Blake's motion. So earlier we made a motion map or a motion diagram of Angela as she was running toward a bus, and it was asking for a motion map of her position. Now it wants a motion map of Blake's motion, not Blake's position. And so our motion maps are going to include arrows. And because Blake is moving at faster than Carlos, they're both on the same train that Angela's watching go by at 5 meters per second. And as Angela watches them both go by at 5 meters per second, Blake is additionally running, he's running faster because he's going as fast as the train plus his speed. Now, when you sketch a motion map based on Carlos's measurement of Blake's motion, Carlos is kind of like included in the 5 meters per second. And so Carlos is only seeing Blake's 2 meters per second. All right. And so Carlos would see Blake running a little bit slower than what Angela would see, since Carlos is not seeing the train's motion included. So if you really want to be careful with this, you would draw like maybe 2 centimeter arrow for Carlos's measurement, and you might draw like a 7 centimeter arrow for here. Let me just jot that down here. So you might make this, or millimeters. I mean, whatever works on your page. This is if you really want to be careful with your motion maps and to scale. It doesn't say to do that, so I'm just kind of like, if you revisit this will make a little bit more sense if this doesn't right now. So part B, data analysis. Use the diagram in part A to determine Blake's speed relative to Angela. Okay, so we kind of did that already. It was a little, the way that I explained it, we kind of already did that. So let's just kind of now write that down, right? It's basically what we're doing. According to Angela, in the reference frame of the Earth, so she's just standing there is in this diagram down here. She's not shown up here, of course. Blake is moving at 2 meters per second east plus the 5 meters per second east that's included with the train car. And so Blake is moving at 7 meters per second to the east, according to Angela. Part C, Blake now turns around and runs at 2 meters per second to the west. According to Angela, use the diagram at the right to determine Blake's velocity relative or according to Angela. According to Angela, in the reference frame of the Earth, I would say that's pretty important to include since we've got a couple different reference frame going on here. You might want to mention that. According to Angela, who is representing all of Earth right now, Blake is moving at 2 meters per second west plus 3 meters per second to the east. Okay, now since Blake turned around and is moving in the opposite direction, we would actually we would consider that to be a negative value, whereas the train is moving in the positive direction. And so 2 meters per second west plus 5 meters per second east gives us 3 meters per second to the east. Okay. In other words, we have negative 2 meters per second plus a positive 5 meters per second. And that would leave us with a positive 3 meters per second. Okay, and since positive is east, then our final answer is east. Okay, so I'm just going to kind of circle that as our final answer. That'll make things a lot clearer to somebody who's reading this. Okay, backside now. In both cases shown below, Blake is running on a train as it travels. In which case is Blake's speed relative to the ground the greatest? Okay, so if you go by what I just got done saying and you start to apply positive and negative values to it, then if you just say, well, over here, Blake is moving negative and the train is moving positive. It's kind of hard to see where I put that. Over here, Blake is moving positive, the train is moving positive. You can kind of get a good idea here. I'll put the positive over here as well. So for the train. So you kind of get an idea of what's about to happen here. And then you can read what the different people said and make your assertion. So it says circle the correct parts of each student's argument. That implies, by the way, if you read that, that implies that something about what each of them said is going to be correct, okay? And that's going to be normal. People often say things like that where maybe they're not completely wrong, but they got some part right and some part wrong. So the directions say to circle the correct parts. Assume that there is a correct part to circle. Okay, so Blake says I'm running the fastest in case A. This is true. Okay, like from his perspective, he's running the fastest. He's running at 20 meters per second. In case B, he's running at 10 meters per second. I don't know about you, but 20 does seem a little bit bigger than 10. So he's running faster in case A. Therefore, I will appear to be moving fastest relative to the ground. Who cares what the train is doing? Now, all of that hopefully was pretty obvious. That is not going to be true because the train does make a difference to anybody observing from the ground. From the reference frame of the ground, the train absolutely has an effect. Carlos, no, the train does matter. And that's about all he said. That's correct. But and here's why. 20 plus 10 is greater than 10 plus 10. You're right that in case A is where Blake is the fastest. So Carlos basically said, yeah, the train matters, but then he didn't say, like he forgot about the direction also matters. So I'm just going to kind of write that here. Direction, exclamation point, times 3. So the direction absolutely matters, okay? I sketched that up here. If you do that right away and just start doing that implicitly, when you have different directions, it's going to help you a lot. It's going to help you tremendously. Angela says Blake is running fastest relative to the ground in case B because, now here's her because, Blake, like you can't just say, like she made a claim, Blake is running fastest relative to the ground in case B. Okay, boom. Yeah, you can circle that. That's fine. But the because is the important part. Blake's velocity and the train's velocity are in the same direction and they add up to 20 meters per second east. But in case A, the velocities are in the opposite direction. And so they cancel each other out. They subtract. You're adding a negative. And so that's why Angela is correct. All right. But more importantly, they're all partly correct. And that's a skill to develop and get better at, is picking out the correct parts of what everybody says. All right? All right.